Hello everyone, welcome to our channel Code with Sunny, and in this video we'll be talking about the first problem, probability of this December circuits 2022. Okay, so if you haven't subscribed to our channel yet, I would recommend you to subscribe that, because we are going to upload quality video editorials of the various CP problems, also the DSA problems. So make sure that you will subscribe it. So let's begin with this problem. Given a tree with n nodes and n minus 1 edges rooted at node 1. Okay. So and also you have to answer q queries. In every query you will be given a node x. So Alice will tell his friend Bob the distance from 1 to x, but Bob only knows how to reach a particular distance from 1. So we need to find the probability that Bob will reach the node x in one try. If p is the probability, then we have to print 1 by p in each query. Okay, so let's try to understand this problem in detail. So we have a tree of n nodes in tree, and since it is a tree, we have this n minus 1 edges. Now and also we need to process q queries. Okay, and in each queries we will be given the node x, and we need to find out the probability of this probability to reach node x, and there will be certain conditions also. Let's try to discuss that also. So there are two persons, Alice and Bob. So in each query you will receive a node x, right? Node x. So there will be some tree like structure that would be given to you. Okay, suppose this is a tree, and this is a node x. This is our node x. Okay, so in each query you need to find out the probability to reach node x. So what Alice says to Bob is like, Alice, like in each query you will be given the node x. So Alice will give you the distance to reach the node x from the rooted node, which is node 1. So you will be given the d equal to distance from node 1 to node x, that will be given by Alice to the Bob. Okay, so Bob has the distance d, okay, and now Bob wants to reach the node x following this distance d. Okay, so Bob is going to cover only the distance d, and what is the probability that if the Bob will cover the distance d, he will reach to the node x? That's what being asked in each queries. So Bob only knows how to reach a particular distance from 1. So we need to find the probability that Bob will reach x in one try. Okay, so let's try to take one example tree. Let's try to understand. So let me take this example. Okay, or let's take some complex example that would be better for you. Let's say we have 1 2 3 and we have this 4, and let's say we have this 5, we have this 6, we have this 7, and let's say we have this 8, we have this 9, we have this 10, and we have this 11. Okay, so suppose in each query you'd be given some node x. Okay, so like we have this query 1, like in the first query, let's say we have been given the node 10. Okay, so this is our node 10. Okay, so what Alice will do is Alice will find out the distance between node 1 and node 10. So d is going to be the distance between node 1 and node 10. So it is coming out to be 2. Okay, so d comes out to be 2. So Alice will give this value to the Bob. So Bob has to reach node 10 following this distance d. Okay, so Bob will have to cover the distance d. Okay, and Bob wants to reach out to the node 10. So what is the probability that Bob will reach out to the node 10 if he is going to cover the distance d equal to 2? Okay, so you can see Bob is at node 1 and distance is equal to 2. So you can reach out to the various nodes if you follow the distance equal to 2. So one of the cases, just go over here, just go over here. So you can reach out to 5 as well, you can reach out to 6 as well, you can reach out to 7 as well. You can see 5, 6 and 7 have the distance equal to 2 from the rooted node, which is 1. Similarly, you can reach out to all these nodes which have distance equal to 2. Okay, so I think I need to change the color, that would be better for you. So okay, so let me erase this one also. You can reach out to all these nodes like node 5, node 6, node 7, node 8, node 9, node 10, node 11. Okay, so Bob has to cover this distance d equal to 2, which is being provided by the allies, and Bob wants to reach out to node 10. So what is the probability that Bob will reach out to the node 10 in one try? Okay, so to cover the distance d equal to 2, you can just reach out to various nodes like node 5, 6, 7, 8, 9, 10, 11. Okay, so what is the probability to reach out to node 10 equal to 1 by, like 1 is going to be for the node 10. If you reach out to the node 10, there will be going to be one possible way. And what are the total possible ways if you cover the distance d equal to 2, and you can reach out to a set of nodes? It would be 5, 6, 7, 8, 9, 10, 11. So there are 7 nodes, so probability is going to be 1 by 7. Okay, so how do you generalize your answer to find out the approach for this problem? Okay, so let me write down. So approach for this problem is, for each query, you will be given the node x, right? So our probability is going to be probability. Let me write down. I'm going to write down the answer. So there is one of the possible way to reach the node x will be 1. So I'm going to write down 1 in the numerator. And what is going to be the value that is going to be present in the denominator? Okay, so denominator is going to be, let's say, I'm just writing down count of level of x. Okay, so let me find out this level of x. So your answer is going to be 1 divided by count of number of nodes present on the level of x. Okay, so if you find out the level of this node x, which remember that rooted node is going to be at level equal to 0, and then all the other nodes is going to be at level equal to 1. Okay, like it would be something called increasing depth. Okay, so if we are able to find out the number of nodes present at the level x, then our probability is going to be 1 by this value. Okay, so how this value is like how this value came about is something like this. You have to cover the distance d, right? And at node x, okay, suppose the node x is present at level some level. Okay, so let's call it as level l dash. Okay, so if you are able to find out the number of nodes present in the level l dash, each will have the distance d from the rooted node, right? So if you are able to find out the number of nodes present in this particular level, then our probability is going to be 1 by count. Okay, so because each node present in that level will have the same distance as of the node x. Okay, so 1 comes for the node x, and let us have the number of nodes present on that particular level of node x as count. So our probability is going to be 1 by count. Okay, so how we are going to find out the level of x? It is going to be simple, using breadth first search. Okay, so if we store all the we will just find out the level of each node, and if you are done with that, then we will just store the number of nodes present in each level. Okay, then for each query, if you have been given the node x, we will just find out 1 divided by number of nodes present on the level of x. Okay, and again I'm just explaining it out like this. Denominator factor comes like very simply, because the distance from the rooted node 1 to the node x is d, and for each node that is present in this level of this node x will have the same distance as of d. Okay, so that's why the total number of nodes is going to be 1 So, total number of nodes is going to be count, and to reach to the node x will going to be like number of ways is 1. So our probability is 1 by count. Okay, so that will be our answer for each query. So also so for each query, if p will be the probability to reach x, then we need to print 1 by p in a separate line. Okay, so it would be something like this. So our probability is let's say p dash is going to be 1 by p, so we have to print 1 by p dash. So nothing but we have to print p actually. So we have to print out number of nodes present on level of x. So indirectly we have to print for each query number of nodes present on the level of x. So let's try to look out for the submitted solution that I have. Okay, so let me open up this one. You can see all the codes are being accepted. Okay, so yeah, I hope the screen is visible. So we have this adjacency list, we have this level, and we have this value of p. Okay, so remember that p is nothing but number of nodes present on this particular level. Okay, so if level is I, so p of I will denote the number of nodes present on the level I. So initially we are just making the adjacency list while taking the input. Now this entire code from here to here is going to have the concept of breadth first search, where we are just trying to find out the level of each node. Okay, so you can see each time if the node is unvisited, we are checking it by the condition level of u is equal to -1. Then we just insert into the queue, and we just make level of u equal to 1 plus level of v. Okay, and finally we are just storing all the like number of nodes present on each level on the p vector. Okay, p array, you can also take an array as it is. So what will be our answer? Our answer will be 1 by p dash. Okay, where p dash is going to be called as probability. So our answer is 1 divided by number of nodes present on the level x. So if you do something like this, 1 upon 1 by count of number of nodes present on the level of x, then you will get the number of nodes present on the level of x. So indirectly for each query, your answer is number of nodes present on the level of x. Okay, so that's what we are just printing over here. Okay, so if you have any queries, you can reach out to me through the comment section of the video, and thank you for watching this video.